I'm going to be doing problem 32 from chapter 11. So a student sits on a freely rotating stool holding two dumbbells, each of mass 3 kilograms. When the student's arms are extended horizontally, the dumbbells are 1 meter from the axis of rotation, and the student rotates with an angular speed of 0.75 radians per second. So for student holding the dumbbells 1 meter from the axis of rotation, and they are each 3 kilograms. And his initial angular speed is 0.75 radians per second. The moment of inertia of the student plus stool is 3 kilogram meter squared and is assumed to be constant. So moment of inertia of the student is 3 kilogram meters squared. The student pulls the dumbbells inward horizontally to a position 0.3 meters from the rotation axis. So, can't see that, sorry. Now the dumbbells are 0.3 meters, 0.3 meters. Find the new angular speed of the student. Okay, so first we need to find the initial moment of inertia of the student and the dumbbells together. So the initial moment of inertia is just the moment of inertia of the student and the weights. So we already know this is 3 kilogram meters squared plus 2 mr squared. We can treat these as point masses. So 3 kilogram meters squared plus 2. They're each 3 kilograms, and they're 1 meter away from the axis of rotation. That comes out to 9 kilogram meters squared. Next, we have to find the final moment of inertia when the student pulls the dumbbells inward. So it's still the student and the weights. 3 kilogram meters squared plus 2 mr squared is 3 kilogram meters squared plus 2 of them. They're each 3 kilograms, but they're 0.3 meters away from the axis of rotation. This comes out to 3.54 kilogram meters squared. So next we're going to use conservation of angular momentum and to figure out the angular speed. So the angular momentum initial is equal to the angular momentum final. Angular momentum is equal to moment of inertia times angular speed. Oops, that's initial. Sorry. And the angular speed final is equal to moment of inertia initial, angular speed initial for moment of inertia final. 9 kilogram meters squared times 0.75 radians per second over 3.54 kilogram per meter squared is equal to 1.91 radians per second. Okay, so for part B of the problem, find the kinetic energy of the rotating system before and after the student pulls the dumbbells inward. Okay, so the kinetic energy can be found using kinetic energy equals to 1/2 moment of inertia angular speed squared. The kinetic energy initial is equal to 1/2 9 kilogram meters squared, 0.75 radians per second squared, is equal to 2.53 joules. The kinetic energy final equal to 1/2 3.54 kilogram meters squared times 1.91 radians per second squared equal to 6.46 joules.